Microsoft Azure Data Fundamental certification is focused towards gaining foundational level knowledge on core data concepts and how they can use those skills to translate that knowledge into Azure data services. DP-900 certification is intended for students who are beginning to work with data in the cloud. After completing this Azure Data Fundamental certification, you can prepare yourself for Azure Data Engineer Associate or Azure Data Administrator Associate certification exams. I will make sure to put the timestamps on all of the topics within this course right below the like button so you will be able to easily navigate between these topics. I hope you enjoy this course and I wish you all the very best and continued success. Let's look at the core skills which Microsoft expect us to understand, and we will be measured on this certification. If you're planning to sit for the exam, you should be able to describe the core data concepts and how to work with relational data on Azure and how to work with non-relational data on Azure as well. And finally, we need to learn about analytics workloads on Azure. Each of these skills have different weightages. The higher the weightage means that the more questions likely gonna come on this examination. I have broken down these skills into different lessons and I have created videos based on these individual lessons. So in total, I have 20 videos which takes you through entire concepts what Microsoft expect you to understand in this examination. If DP-900 is the first Microsoft examination you are planning to sit, then you need to understand some tips as well. When you sit for the exam, you can expect questions between 40 to 60. Each questions are worth more than 1 point. Try to answer all the questions because there is no penalty for guessing or there is no penalty or negative mark for wrong answers. In total, you will have 180 minutes, but plan for at least 150 minutes for answering the questions and 30 minutes for instructions, commenting, reporting, etc. Sometimes there can be more than multiple choice questions as well. You will sometimes get match the following, built list, hot area, active screen, drag and drop, etc. For DP-900, there is not going to be any case studies or labs. For advanced examination, you can expect case studies or lab scenarios as well. In the first lesson, we're going to explore core data concepts. So let's look at the learning objectives for this episode. We will start with how to identify how data is defined and stored, and we will identify what are the characteristics of relational and non-relational data. We will describe and differentiate different types of data workloads, and we will try to describe and distinguish batch and streaming data as well. So without wasting any more time, let's get into it. So what is data? Data is a collection of facts such as numbers, descriptions, and observations used in decision making. You can classify data as structured, semi-structured, or unstructured. Structured data is typically tabular data that is represented by rows and columns in a database. Databases that hold tables in this form is called relational databases. The mathematical term relation refers to an organized set of data held as a table. Each row in a table has the same set of columns. This image illustrates an example showing two tables in an e-commerce database. The first table contains the details of customers for an organization, and the second holds information about products that the organization sells. Now let's understand what is semi-structured data. A semi-structured data is information that doesn't reside in a relational database, but still has some structure to it. Examples include documents held in JavaScript object notation or JSON format. This example shows a document representing customer information. In both these cases, each customer documents include child document containing the name and address. But the fields in these child documents vary between customers. So what is the third kind? The third kind is unstructured data. Not all data is structured or even semi-structured. For example, audio and video files and binary data files might not have a specific structure. They are referred as unstructured data.
There are other types of semi-structured data as well. These examples include key value stores and graph databases. A key value store is similar to a relational table, except that each row can have any number of columns. And the second type is graph databases. You can use a graph database to store and query information about complex relationships. A graph contains nodes, which is information about objects, and edges, which is information about the relationship between objects. This image shows an example of how you might structure the data in a graph database. Data processing solutions often fall into one of two broad categories. It's either analytical systems and transaction processing systems. So, what is transactional system? A transactional system is often what most people consider the primary function of business computing. A transactional system records transactions. A transaction could be financial, such as a movement of money between account in a banking system, or it might be part of retail system, such as tracking payments for goods and services from customers. Think of a transaction as a small, discrete unit of work. And transactional systems are often high volume, sometimes handling many million transactions in a single day. The data being processed has to be accessible very quickly. The work performed by the transactional system is often referred to as online transactional processing, or OLTP. To support fast processing, the data in a transactional system is often divided into small pieces. For example, if you are using a relational system, each table involved in a transaction only contains the columns necessary to perform the transactional task. And normalization can enable a transactional system to cache much of the information required to perform transaction in memory and speed throughput. Now let's understand what is analytical system. In contrast to system designed to support OLTP, an analytical system is designed to support business users who need to query data and gain a big picture view of the information held in a database. Analytical systems are concerned with capturing raw data and using it to generate insights. An organization can use these insights to make business decisions. For example, detailed insight for a manufacturing company might indicate trends enabling them to determine which product lines to focus on for profitability. And most analytical data systems need to perform similar tasks like data injection, data transformation, data querying, and data visualization. This is an example image which illustrates the components in a typical data processing systems. Let's look at these four components one by one. So, what is data injection? Data injection is the process of capturing the raw data. This data could be taken from control devices measuring environmental information such as temperature and pressure, or point of sale devices recording the items purchased by a customer in a supermarket, or financial data recording the movement of the money between bank accounts, or weather data from weather stations. Some of this data might come from a separate OLTP system as well. To process and analyze this data, you must first store the data in a repository of some sort. The repository could be a file store, a document database, or even a relational database. And you can keep the data in Azure SQL database or any other storage platform, which we are going to mention in the later videos. The next step is data processing. The raw data might not be in a format that is suitable for querying. The data might contain anomalies that should be filtered out, or it may require transforming in some way. So, after the data is ingested into the data repository, you may want to do some cleaning operations and remove any questionable or invalid data. And finally, data visualization. Data represented in tables such as rows and columns or documents aren't always intuitive. Visualizing the data can be often be useful as a tool for examining data. You can generate charts such as bar charts, line charts, plot results, or geographical maps, pie charts, or illustrate how data changes over time. Microsoft offers visualization tools like Power BI to provide rich graphical representation of your data. Let's understand the difference between batch and streaming data. Data processing is simply the conversion of raw data to meaningful information through a process. Depending on how the data is ingested in your system, you could process each data as it arrives, or buffer the raw data and process it in groups. Processing as it arrives is called streaming, and buffering and processing the data in groups is called batch processing. Let's understand streaming and batch processing in detail. In batch processing, newly arriving data elements are collected into a group. The whole group is then processed at a future time as a batch. Exactly when each group is processed can be determined in the number of ways. For example, you can process data based on scheduled time interval, or it could be triggered when a certain amount of data has arrived, or as a result of some other event. An example of batch processing is the way that credit card companies handle billing. The customer doesn't receive a bill for each separate credit card purchase, but one monthly bill for all that month's purchase. So let's look at some of the advantages of batch processing. Large volumes of data can be processed at a convenient time. Another advantage is it can be scheduled to run at a time when computers or system might otherwise be idle, such as overnight or during off-peak hours. Some of the disadvantages of batch processing are the time delay between ingesting the data and getting the results. Alright, so now let's understand the streaming data. In stream processing, each new piece of data is processed when it arrives. For example, data ingestion is inherently a streaming process, and streaming handles data in real time. Unlike batch processing, there is no waiting until the next batch processing interval, and data is processed as individual pieces rather than being processed a batch at a time. Streaming data processing is beneficial in most scenarios where new dynamic data is generated on a continual basis. So, what are the examples of streaming data? So, one example could be a financial information tracks changes in the stock market in real time. Another example could be an online gaming company collects real time data about player game interactions. And the third example could be a real estate website that tracks a subset of data from customers' mobile devices and makes real time property recommendations for properties to visit based on their geolocation. Apart from the way in which batch processing and streaming processing handle data, there are other differences as well. So let's look at that one by one. The first one is data scope. Batch data can process all the data in the data set. Stream processing typically only has access to the most recent data received or within a rolling time window, the last 30 seconds, for example. The next difference is about data size. Batch data is suitable for handling large data set efficiently, and stream processing is intended for individual records or micro batches consist of few records. And the third difference is the performance. The latency for batch processing is typically a few hours. Stream processing typically occurs immediately, with latency in the order of seconds or milliseconds. Latency is the time taken for the data to be received and processed. And the last difference is analysis. You typically use batch processing for performing complex analytics. Stream processing is used for simple response functions, aggregates, or calculations such as rolling averages. So that concludes our episode 2. In this video, we're going to learn about roles and responsibilities in the world of data. And in this lesson, there is two objectives. We're going to explore the data job roles, and we're going to explore the common tasks and tools for data job roles. So without wasting any more time, let's get into it. There's a wide variety of roles involved in managing, controlling, and using data. Some roles are business oriented, some involve more engineering, and some focus on research. And some are hybrid roles that combine different aspects of data management. In this video, I will take you through some of the most common job roles in the world of data. Your organization may define roles differently or give them different names, but the roles described in this video encapsulate the most common division of labor and responsibility. So, what are the roles in the world of data? There are primarily three key job roles that deal with data in most organizations. And those roles are database administrator, data engineer, and data analyst. So, let's go through these one by one. First, let's understand what is a job responsibility of a database administrator. This could be an Azure database administrator as well. An Azure database administrator is responsible for the design, implementation, maintenance, and operational aspect of on-premises and cloud-based database solutions built on Azure Data Services and SQL Server. They are responsible for the overall availability and consistent performance and optimization of the database solutions. They work with the stakeholders to implement policies, tools, and processes for backup and recovery plans. The database administrator is also responsible for managing the security of the data in the database, granting privileges over the data, and granting or denying access to users as appropriate. The second role is a data engineer role. A data engineer collaborates with stakeholders to design and implement data related assets that include data ingestion pipelines, cleansing and transformation activities, and data stores for analytical workloads. They use a wide range of data platform technologies, including relational and non relational databases for file stores and data streams. Data engineers are also responsible for ensuring that the privacy of the data is maintained within the cloud and spanning from on premises to the cloud data store. And data engineer also own the management and monitoring of the data stores and data pipelines to ensure that data loads perform as expected. And the third role we are going to understand today is all about data analyst role. A data analyst enables business to maximize the value of the data assets. They are responsible for designing and building scalable models, cleansing and transforming data, and enabling advanced analytic capabilities through reports and visualizations. A data analyst processes raw data into relevant insight based on identified business requirement to deliver relevant insights. Let's understand some of the common tools database administrators use. Most database management systems provide their own set of tools to assist with database administration. For example, SQL Server database administrators use SQL Server Management Studio. Other systems have their own database specific interfaces as well, such as pgadmin for PostgreSQL systems or MySQL Workbench for MySQL. There are also a number of cross platform database administration tools available as well. One example is Azure Data Studio. So let's understand what is Azure Data Studio. Azure Studio provides a graphical user interface for managing many different database systems. It currently provides connections to on-premises SQL Server databases, Azure SQL Database, PostgreSQL, Azure SQL Data Warehouse, and SQL Server Big Data clusters, among others. It's an extensible tool, and you can download and install extensions from third-party developers that connect to other systems or provide wizards that help to automate many administrative tasks. What is an SQL Server Management Studio? SQL Server Management Studio provides a graphical interface enabling you to query data, perform general database administration tasks, and generate scripts for automating database maintenance and support operations. This example picture I mentioned over here shows that SQL Management Studio is being used to back up a database. A useful feature of SQL Server Management Studio is the ability to generate transact SQL script for almost all the functionality that SSMS provides. This gives the DBA the ability to schedule and automate many common tasks. Another option is to use the Azure portal to manage Azure SQL Database. Azure SQL Database provides database services in Azure. It's similar to SQL Server, except that it runs in the cloud. You can manage the Azure SQL Database using the Azure portal. Typical configuration tasks such as increasing the database size, creating a new database, and deleting an existing database are done using the Azure portal. You can use the Azure portal to dynamically manage and adjust resources such as data storage size and the number of cores available for the database processing. These tasks would require the support of a system administrator if you are running the database on premises. Let's understand some of the common data engineering tools. To master data engineering, you will need to be familiar with a range of tools that enable you to create a well-designed databases optimized for the business processes that will be run. You must have a thorough understanding of the architecture of the database management system, the platform on which the system runs, and the business requirements for the data being stored in the database. If you are using a relational database management system, you need to be fluent in SQL, and you must be able to use SQL to create databases, tables, indexes, views, and other objects required by the database. In some cases, you may need to interact with the database from a command line. Many database management systems provide a command line interface that supports these operations. For example, you can use the SQL CMD utility to connect to the Microsoft SQL Server and Azure SQL Database and run ad hoc queries and commands. Let's look at some of the common tools used by data analysts. Data analysts are responsible for understanding what data actually means. A skilled data analyst will explore the data and use it to determine trends, issues, and gain other insights that might be of benefit to the company. A large part of the data analyst role is concerned with communication and visualization. Data visualization is a key to presenting large amounts of information in ways that are universally understandable or easy to interpret and spot patterns, trends, and correlations. These representations include charts, graphs, infographics, and other pictorial diagrams. A good data analyst requires experience and skill in reporting tools such as Microsoft Power BI and SQL Server reporting services. Traditionally, many data analysts used Microsoft Office apps such as Microsoft Excel for creating rich visual reports. Many analysts now use Microsoft Power BI, a powerful visualization platform, to create rich graphical dashboards and reports over data that can vary dynamically. This image shows an example of a dashboard created using Power BI. In this example, the analyst is using Power BI to examine retail sales data for items sold across multiple stores and districts. The metrics compare this year's performance to last year's for sales, units, gross margin, and variance, as well as new store analysis. Alright, so that concludes this lesson. In this video, we're going to learn about how to describe concepts of relational data. And in this lesson, we will learn about exploring the characteristics of relational data. You would be able to define tables, indexes, and views. And we will explore the relational data workload offering in Azure as well. So without wasting any more time, let's get into it. Let's understand tables. In a relational database, you model collections of entities from the real world as tables. An entity is described as a thing about which information need to be known or held. A table contains rows, and each row represents a single instance of an entity. The rows in a table have one or more columns that defines the property of the entity, such as the customer name or the product ID, etc. All rows in the same table have the same columns. Some columns are used to maintain relationship between tables. This is where the relational model gets its name from. Let's look at this example. The order table contains both a customer ID and a product ID. The customer ID relates to the customer table to identify the customers that placed the order, and the product ID relates to the products table to indicate what products was purchased. So you design a relational database by creating a data model. So this model shows the structure of the entities from the previous example. In this diagram, the columns marked PK are the primary key for the table. The primary key indicates the column that uniquely identify each row. Every table would have a primary key. And the diagram also shows the relationship between these tables. The lines connecting the tables indicate the type of relationship. In this case, the relationship from customers to orders is one to many. Similarly, the relationship between orders and products is many to one. Please note that creating a relational database model for a large organization is not a trivial task. It can take several iterations to define tables to match the characteristics based on the example what we have seen before. Sometimes you have to split an entity into more than one table. This process is called normalization. A relational database comprises a set of tables. A table can have 0 or more rows. Each table has a fixed set of columns. You can define relationship between tables using primary and foreign keys, and you can access the data in the table using SQL. So what is an index? An index helps you search for data in a table. Think of an index or a table like an index at the back of a book. When you create an index in a database, you specify a column from the table, and the index contains a copy of this data in a sorted order, with pointers to the corresponding rows in the table. And you can create as many indexes as you want on a table. However, indexes aren't free. An index might consume additional storage space, and each time you insert, update, or delete data in a table, the indexes of the table must be maintained. This additional work can slow down insert, update, and delete operation and incur additional processing charges. So what is a view? A view is a virtual table based on the result set of a query. In the simplest case, you can think of a view as a window on specified rows in an underlying table. You can query the view and filter the data in much the same way as a table. A view can also join tables together. If you regularly needed to find the details of customers and the product that they have ordered, you could very well create a view based on a join query. Let's understand what is IaaS and PaaS. This is very important for us going forward for all the other topic we are going to discuss today. So IaaS is an acronym for Infrastructure as a Service. Azure enables you to create virtual infrastructure in the cloud that mirrors the way an on-premises data center might work. You can create a set of virtual machines, connect them together using a virtual network, and add a range of virtual devices. In many ways, this approach is similar to the way in which you run your systems inside an organization, except that you don't have to concern yourself with buying or maintaining the hardware. However, you are still responsible for many of the day-to-day operations such as installing, configuring the software, patching, taking backup, and restoring data when needed. You can think of IaaS as a halfway house to fully manage operations in the cloud. You don't have to worry about the hardware, but running and managing the software is still very much your responsibility. The IaaS approach is the best for migrations and applications requiring operating system level access. So what is PaaS? PaaS stands for Platform as a Service. Rather than creating a virtual infrastructure and installing and managing the database software yourself, a PaaS software does this for you. You specify the resources that you require, and Azure automatically creates the necessary virtual machines, network, and other devices for you. You can usually scale up or down based on your requirement. and you don't have to manually add or remove virtual machines or perform any other form of configuration. So Azure offers several PaaS solutions for relational databases, including Azure SQL Database, Azure Database for PostgreSQL, Azure Database for MySQL, and Azure Database for MariaDB. These services run managed versions of the database management system on your behalf. So you just connect to them, create your database, and upload your data. However, you may find that there are some functional restrictions in place, and not every feature your selected database management system may be available. So these restrictions are often due to the security issues. Alright, so that concludes this lesson. In this lesson, we're going to explore concepts of non-relational data. On a high level, we're going to learn about how to explore the characteristics of non-relational data. You will learn about how to define types of non-relational data, and you would be able to understand how to describe NoSQL and the types of non-relational databases. So without wasting any more time, let's get into it. Relational databases are an excellent tool for storing and retrieving data that has a well-known structure containing fields that you can define in advance. In some situations, you might not have the required knowledge of the structure of your data. This is a common scenario in systems that consume data from a wide variety of sources, such as data ingestion pipelines. In these scenarios, non-relational database can prove extremely useful. So let's understand what are the characteristics of non-relational data. You use database to model some aspect of the real world. Entities in the real world often have highly variable structures. For example, in an e-commerce database that stores information about customers, how many telephone numbers does a customer have? A customer might have a landline and a mobile number, but some customers might have a business number, an additional home number, and maybe several mobile numbers. Similarly, the address of customer might not always follow the same format. Addresses of customers in different states and regions might contain different elements such as zip code or postal codes. In other scenario, you are ingesting data rapidly and you want to capture the data and save it very quickly. Processing the data and manipulating it into set of rows in different tables in a relational database might not be appropriate at this point. You can perform these tasks as part at a later date. At the time of ingestion, you simply need to store the data in its original state and format. So a key aspect of non-relational database is that they enable you to store data in a very flexible manner. So non-relational database don't impose a schema on a data. Instead, they focus on the data itself rather than how to structure it. This approach means that you can store information in a natural format that mirrors the way in which you would consume, query, and use it. In a non-relational system, you store the information for entities in collections or containers rather than relational tables. Two entities in the same collection can have a different set of fields rather than a regular set of columns found in a relational table. The lack of fixed schema means that each entity must be self-describing. In this example, I mentioned about a non-relational collection of customer entities, so it looks like this. So the fields are prefixed with a name, and fields might also have multiple subfields and also with names. In this example, multiple subfields are denoted by enclosing them in a square bracket. More advanced non-relational systems support indexing in a similar manner to an index in a relational database. Queries can then use the index to identify and fetch data based on non-key fields. Non-relational systems such as Azure Cosmos DB support indexing even when the structure of the indexed data can vary from record to record. So when you design a non-relational database, it's important to understand the capabilities of the database management system and type of query it will have to support. And please note that non-relational database often provide their own proprietary language for managing and querying data. This language may be procedural or it may be similar to SQL. It depends on how the database is implemented by the database management system. So let's identify some of the non-relational database use cases. The first use case is IoT and telemetrics. These systems typically ingest large amounts of data in frequent bursts of activity. Non-relational database can store this information very quickly, and the data can then be used by analytics services such as Azure Machine Learning, Azure HD Insight, and Microsoft Power BI. Additionally, you can process the data in real time using Azure functions, and that are triggered as data arrives in the database. The second scenario is retail and marketing. Microsoft uses Cosmos DB for its own e-commerce platforms that run as part of Windows Store and Xbox Live. It is also used in the retail industry for storing catalog data and for event sourcing in order processing pipelines. The next use case scenario is for gaming. So the database tier is a crucial component of gaming applications. Modern games perform graphical processing on mobile or console clients, but rely on the cloud to deliver customized and personalized content like in game stats, social media integration, and high score leaderboards. Games often require single millisecond latencies for read and write to provide an engaging in game experience. A game database needs to be fast and able to handle massive spike in request rate during new game launches and feature updates. Let's look at one more use case scenario. This time it is for web and mobile applications. A non-relational database such as Azure Cosmos DB is commonly used within web and mobile applications and is well suited for modeling social interactions, integrating with third-party services, and for building rich personalized experiences. So the Cosmos DB SDK can be used to build rich iOS and Android applications using the popular Xamarin framework. So this non-relational data generally fits into two categories: semi-structured and non-structured. So what is semi-structured data? Semi-structured data is the data that contains fields. The fields don't have to be the same in every entity. You only define the fields that you need on a per entity basis. One of the common ways of doing this is to store the data for each entity as a JSON document. The term JSON stands for JavaScript Object Notation. It's the format used by JavaScript application to store data in memory, but can also be used to read and write documents to and from files as well. Let's look at the other format. Avro is a row-based format. It was created by Apache. Each record contains a header that describes the structure of the data in the record. This header is stored as JSON. The data is stored as binary information. An application uses the information in the header to parse the binary data and extract the fields it contains. Avro is very good format for compressing data and minimizing storage and network bandwidth requirements. The next format is ORC, which is optimized row columnar format. ORC organizes data into columns rather than rows. It was developed by Hortonworks for optimizing read and write operations in Apache Hive. Hive is a data warehousing system that supports fast data summarization and querying over very large data sets. Hive supports SQL-like queries over unstructured data. And the next format is Parquet. Parquet is another columnar data format. It was created by Cloudera and Twitter. A Parquet file contains row groups. Data for each column is stored together in the same row group. Each row group contains one or more chunks of data. So let's understand what is unstructured data. Unstructured data is the data that doesn't naturally contain fields. Examples include video, audio, and other media streams. Each item is an amorphous blob of binary data. You can't search for specific elements in this data. You might choose to store data such as this in storage that is specifically designed for this purpose. In Azure, you would probably store video and audio data as block blobs in an Azure storage account. A blob only supports basic read and write operations and has no internal search capability. You could also consider files as a form of unstructured data, although in some cases, file might include metadata that indicates what type of file it is. Is it a photograph, Word document, Excel spreadsheet, and so on? You could also consider files as a form of unstructured data, although in some cases, file might include metadata that indicate what type of file it is, like photograph, Word document, Excel spreadsheet, and so on. However, the main content of the file is unstructured. So let's understand what is NoSQL. You might see the term NoSQL when reading about non-relational databases. NoSQL is rather loose term that simply means non-relational. Some non-relational databases support a version of SQL adapted for documents rather than tables. NoSQL databases generally fall into four categories: key value stores, document databases, column family databases, and graph databases. So, what is key value store? A key value store is the simplest type of NoSQL database for inserting and querying data. Each data item in a key value store has two elements: a key and a value. A key uniquely identifies the item, and the value holds the data for the item. The value is opaque to the database management system, and items are stored in key order. Let's understand what is a document database. A document database represents the opposite end of the NoSQL spectrum from a key value store. In a document database, each document has a unique ID, but the fields in the documents are transparent to the database management system. Document databases typically store data in JSON format, or they could be encoded using other formats such as XML, YAML, JSON, or BASON. Documents could even be stored as plain text. The fields in documents are exposed to the storage management system, enabling an application to query and filter data by using the values in these fields. So, what is a column family database? A column family database organizes data into rows and columns. Example of this structure include ORC and Parquet files. In its simplest form, a column family database can appear very similar to a relational database, at least conceptually. The real power of a column family database lies in its denormalized approach to structuring sparse data. And the last one is graph databases. Graph databases enable you to store entities, but the main focus is on relationships that these entities have with each other. A graph database stores two types of information: nodes that you can think of as instances of entities, and edges, which specify the relationship between nodes. Nodes and edges can both have properties that provide information about that node or edge. Additionally, edges can have a direction indicating the nature of the relationship. The purpose of the graph database is to enable an application to effectively perform queries that traverse the network of nodes and edges and to analyze the relationship between entities. Let's look at this image for an example. This shows an organization's personal database structured as a graph. The entities are the employees and the departments in the organization, and the edges indicate reporting lines and department in which employees work. In this graph, the arrows on the edges show the direction of the relationship. A structure such as this makes it straightforward to conduct inquiries such as find all employees who directly or indirectly work for Sarah, or who works in the same department as John. Azure Cosmos DB supports graph databases using Gremlin API. The Gremlin API is a standard language for creating and querying graphs. So that concludes this lesson. In this video, we're going to explore the concepts of data analytics. In this lesson, we will learn about data ingestion and processing. We will explore the data visualization aspect, and we will explore the data analytics part of it. So without wasting any more time, let's get into it. So first, let's understand what is data ingestion. Data ingestion is the process of obtaining and importing data for immediate use or storage in a database. The data can arrive as a continuous stream or it may come in batches, depending on the source. The purpose of the ingestion process is to capture the data and store it. This raw data can be held in a repository such as a database management system, a set of files, or some other type of fast, easily accessible storage as well. The ingestion process might also perform filtering. For example, ingestion might reject suspicious, corrupt, or duplicated data. Suspicious data might be data arriving from an unexpected source. Corrupt or duplicate data could be due to a device error, transmission failure, or tampering. It may also be possible to perform some transformations at this stage, converting data into a standard form for later processing. For example, you might want to reformat all date and time data to use the same date and time representations and convert all measurement data to use same units. However, these transformations must be quick to perform. Don't attempt to run any complex calculations or aggregations on the data at this stage. So let's understand what is data processing. The data processing stage occurs after the data has been ingested and collected. Data processing takes the data in its raw form, cleans it, and converts it into a more meaningful format, such as tables, graphs, documents, and so on. The result is a database of data that you can use to perform queries and generate visualizations, giving it the form and context necessary to be interpreted by computers and used by employees throughout an organization. Please note that data cleaning is a generalized term that contains a range of actions, such as removing anomalies and applying filters and transformation that would be too time consuming to run during the ingestion stage. The aim of data processing is to convert the raw data into one or more business models. A business model describes the data in terms of meaningful business entities and may aggregate items together and summarize information. The data processing stage could also generate predictive or other analytical models from the data. And the data processing can be complex and may involve automated scripts and tools such as Azure Data Bricks, Azure Functions, and Azure Cognitive Services to examine and reformat the data and generate models. A data analyst could use machine learning to help determine future trend based on these models. So the data processing mechanism can take two approaches to retrieving the ingested data: processing this data to transform it and generate models, and then saving the transformed data and models. These approaches are known as ETL and ELT. So, what is ETL? ETL stands for extract, transform, and load. The raw data is retrieved and transformed before being saved. The extract, transform, and load steps can be performed as a continuous pipeline of operations. It is suitable for systems that only require simple methods with little dependency between items. For example, this type of process is often used for basic data cleaning tasks, deduplicating data, and reformatting the contents of individual fields. An alternative approach is ELT. ELT is an abbreviation for extract, load, and transform. The processes differs from ETL in that the data is stored before being transformed. The data processing engine can take an interactive approach, retrieving and processing the data from storage before writing the transformed data and models back to storage. ELT is more suitable for constructing complex models that depend on multiple items in the database, often using periodic batch processing. Let us explore data visualization. A business model can contain an enormous amount of information. The purpose of producing a model such as this is to help you reason over the information it contains, ask questions, and hopefully obtain answers that can help you drive your business forward. So, reporting is the process of organizing data into information summaries to monitor how different areas of the organizations are performing. So, reporting helps companies monitor their online business and know when data falls outside the expected ranges. Good reporting should raise questions about the business from its end users. Reporting shows you what has happened, while analysis focus on explaining why it happened and what you can do about it. So before we understand the visualization, let me explain you what is a business intelligence. The term business intelligence or BI refers to technologies, applications, and practices for the collection of integration, analysis, and presentation of business information. The purpose of business intelligence is to support better decision making. So now let's understand what is data visualization. Data visualization is the graphical representation of the information and data. By using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to spot and understand trends, outliners, and patterns in data. If you are using Azure, the most popular data visualization tool is Power BI. Using Power BI, you can connect to multiple different sources of data and combine them into a data model. And this data model lets you build visuals and collections of visuals you can share as reports with other people inside your organization. And the last topic of this video is data analytics. So let's explore different categories in detail. Data analytics is concerned with examining, transforming, and arranging data so that you can study it and extract useful information from it. So let's look at the first one, which is descriptive analytics. Descriptive analytics help answers question about what has happened based on historical data. Descriptive analytics technique summarizes large data sets to describe outcomes to stakeholders. What is diagnostic analytics? Diagnostic analytics helps answer questions about why things happened, and diagnostic analytics techniques supplement more basic descriptive analytics. They take the findings from descriptive analytics and dig deeper to find the cause. The performance indicators are further investigated to discover why they got better or worse. The next category is predictive analytics. Predictive analytics help answer questions about what will happen in the future. And predictive analytics techniques use historical data to identify trends and determine if they are likely to recur. And predictive analytical tools provide valuable insight into what may happen in the future. Techniques include a variety of statistical and machine learning techniques such as neural network, decision trees, and regression. The fourth category is prescriptive analytics. Prescriptive analytics helps answers questions about what action should be taken to achieve a goal or target. By using insights from predictive analytics, data-driven decisions can be made. These techniques allow business to make informed decisions in the face of uncertainty. And prescriptive analytics techniques rely on machine learning strategies to find patterns in large data sets. By analyzing past decisions and events, the likelihood of different outcomes can be estimated. And the last one is cognitive analytics. Cognitive analytics attempts to draw inferences from existing data and patterns and derive conclusions based on existing knowledge bases, and then add these findings back into the knowledge base for future inferences, something like a self learning feedback loop. And cognitive analytics helps you to learn what might happen if circumstances change and how you might handle these situations. All right, so that concludes this lesson, and that was the end of the first module. In this video, we're going to test our knowledge based on what we have learned in the previous module. So, without wasting any more time, let's get into it. So, the first question is, how is the data in a relational table organized? Is it based on pages and paragraphs? Definitely not. Is it based on headers and footers? No. So, the correct answer is rows and columns. Structured data is typically tabular data that is represented by rows and columns in a database table. Let's look at question number 2. Which of the following is an example of the unstructured data? Is it an employee table with columns employee ID, employee name, and employee designation? Definitely not. Is it a table within SQL Server database? No. Is it audio and video files? Absolutely correct. So the correct answer is audio and video files. Typically, audios and video files are unstructured data. Let's look at question number 3. What of the following is an example of a streaming data set? Is it a list of employees working for a company? Definitely not. That is static. Or a little dynamic, but not exactly static. Is it sales data from the past month? Definitely not. Is it the data from sensor feeds? Absolutely correct. Sensor and device feeds are examples of streaming data sets as they are published continuously. Let's look at question number 4. Which one of the following tasks is a role of a database administrator? Is it identifying data quality issues? No. Is it creating dashboards and reports? Definitely not. So the correct answer is backing up and restoring databases. Database administrators will back up the database and will restore the database when the data is lost or corrupted. Let's look at question number 5. Which of the following tools is a visualization and reporting tool? Is it SQL Server Management Studio? No. Is it SQL? Definitely not. So the correct answer is Power BI. Power BI is a standard tool for creating rich graphical dashboards and reports. Let's go through the next question. Which one of the following roles is not a data job role? Is it database administrator? Definitely not. Is it data analyst? Definitely a data job. Is it systems administrator? Absolutely correct. Systems administrators deal with infrastructure components such as network, virtual machine, and other physical devices in a data center. Let's look at question number 7. Which one of the following statement is a characteristics of relational database? So I'm going to read out these statements to see which one makes sense. All data must be stored as character strings. Definitely doesn't make any sense. Different rows in the same table can contain different columns. Definitely not the right answer. A row in a table represents a single entity. Absolutely correct. Each row in a table contains the data for a single entity in that table. That is called relational database. That is a characteristic of a relational database. Let's look at question number 8. What is an index? Is it a structure comprising rows and columns that you use for storing data? Definitely not. Is it a virtual table based on result set of a query? Definitely not. So the correct answer is a structure that enables you to locate rows in a table quickly using an indexed value. You create indexes to help speed up queries. The whole reason of using indexes is to speed up queries. Let's look at the next question. Which one of the following statements is a benefit of using PaaS service instead of an on-premises system to run your database management system? Is it increased day-to-day management cost? Definitely not. Is it increased functionality? Definitely not. So the correct answer is increased scalability. PaaS solutions enable you to scale up and out without having to procure your own hardware. Let's look at question number 10. Which of the following services should you use to implement a non-relational database? Is it a Gremlin API? No. Is it Azure SQL Database? Absolutely not. So the correct answer is Azure Cosmos DB. Azure Cosmos DB support several common models non-relational database include key value stores, graph database, document databases, and column family stores. Which of the following is a characteristics of non-relational databases? Is it a non-relational database contain tables with flat fixed column records? No. Is a non-relational database require you to use data normalization technique to reduce data duplication? No. So the correct answer is non-relational databases are either schema-free or have relaxed schemas. Each entity in a non-relational database only has the field it needs, and these fields can vary between different entities. Let's look at question number 12. Wow, that's a long question. You are building a system that monitors the temperature throughout a set of office blocks and sets the air conditioning in each room in each block to maintain a pleasant ambient temperature. Your system has to manage the air conditioning in several thousand buildings spread across the country or region, and each building typically contains at least 100 air conditioned rooms. What type of NoSQL data store is most appropriate for capturing the temperature data to enable it to be processed quickly? So, is it write the temperature to the blob in Azure Blob Storage? Definitely not. Is it column family database? That doesn't work either. So, the correct answer is a key value store. A key value store can ingest large volume of data rapidly. A thermometer in each room can send the data to the database. So let's look at question number 13. What is data ingestion? Is it the process of transforming raw data into models containing meaningful information? No. Is it analyzing data for anomalies? No. So the correct answer is capturing raw data streaming from various sources and storing it. The purpose of data ingestion is to retrieve raw data and save it as quickly as possible. And the data can be processed and analyzed. Let's look at question number 14. Which one of the following visuals display the major contributors to a selected result or value? Is it metric chart? No. It is definitely not column and bar chart. The correct answer is key influencers. A key influencer chart displays the major contributors to a selected result or value. And key influencers are a great choice to help you understand the factors that influence a key metric. Let's look at the last question. Which type of analytics helps answer questions about what has happened in the past? Is it predictive analytics? No. Is it prescriptive analytics? Definitely not. So the correct answer is descriptive analytics. Descriptive analytics help answers question about what happened. All right, so that concludes module 1. We just finished knowledge check on module 1. The next video, we are entering a brand new module. And the first lesson, what we are going to learn in module 2 is all about exploring relational data offerings in Azure. In this lesson, we will learn about how to identify relational Azure data services, and we will explore how to provision and deploy these relational database offerings in Azure, and how you can query relational data in Azure as well. So without wasting any more time, let's get into it. So the first option we are going to discuss today is Azure Virtual Machine in Azure, which falls under Infrastructure as a Service. So SQL Server on virtual machines enable you to use full versions of SQL Server in the cloud without having to manage any on-premises hardware. This is an example of an Infrastructure as a Service approach. An SQL Server running on an Azure virtual machine effectively replicates the database running on real on-premises hardware. Migrating from the system running on-premises to an Azure virtual machine is no different than moving the databases from one on-premises server to another. So this approach is suitable for migrations and applications requiring access to operating system features that might be unsupported at the PaaS level. SQL virtual machines are lift and shift ready for existing applications that require fast migration to the cloud with minimal changes. And please note that the term lift and shift refers to the way in which you can move a database directly from an on-premises server to an Azure virtual machine without requiring that you make any changes to it. Applications that previously connected to an on-premises database can be quickly reconfigured to connect to the database running on a virtual machine, but should otherwise remain unchanged. And this approach is optimized for migrating existing application to Azure as well, or extending existing on-premises application to the cloud in hybrid deployments. The next option is Azure SQL Database, which is running in platform as a service. So if you don't want to incur the management overhead associated with running SQL Server on an Azure virtual machine, you can use Azure SQL Database. So what is an Azure SQL Database? An Azure SQL Database is a platform offering from Microsoft. You create a managed database server in the cloud and then deploy your databases on this server. Please note that a SQL Server database server is a logical construct that acts as a central administrative point for multiple single or pool databases. An Azure SQL database is available with several options: single database, elastic pool, and managed instance. All right, so first let's understand what is Azure SQL single database. So this option enables you to quickly set up and run a single SQL Server database. You create and run a database server in the cloud, and you access your database through this server. And Microsoft manages the server. So all you have to do is configure the database, create your tables, and populate them with your data. You can scale the database if you need additional storage spaces, memory, or processing power. By default, resources are pre-allocated and you are charged per hour for the resources you are requested. You can also specify a serverless configuration as well. In this configuration, Microsoft creates its own server, which might be shared by a number of databases belonging to other Azure subscriptions. And Microsoft ensures the privacy of your database. Your database automatically scales and resources are allocated or deallocated as requested. So what is Azure SQL Elastic Pool? This option is similar to single database, except that by default, multiple databases can share the same resources, such as memory, data storage space, and processing power. The resources are referred to as a pool, and you create the pool, and only your database can use the pool. This model is useful if you have databases with resources required that vary over time, and can help you reduce the cost as well. For example, your payroll database might require plenty of CPU power at the end of each month, but at other times the database might become much less active. So you might have another database that is used for running reports. So this database might become active for several days in the middle of the month as management reports are generated. But with a tighter load at other times, Elastic Pool enables you to use the resources available in the pool and then releases the resources once processing has completed. So what are the use cases for single and Elastic Pool? So Azure SQL Database gives you the best option for low cost with minimal administration. It is not fully compatible with on-premises SQL Server installations. It is often used for new cloud projects where the application design can accommodate any required changes to your applications. Please note that you can use DMA or Data Migration Assistant to detect compatibility issues with your database that can impact database functionality in Azure SQL Database. So Azure SQL Database is often used for any sort of modern cloud application that need to use the latest stable SQL Server features and applications that require high availability. And one more place where you can think of where to use Azure SQL Database is for systems with a variable load that need the database server to scale up and down quickly. Alright, so now we understood SQL Server on an Azure virtual machine and an SQL Server database. So within an Azure SQL database, we talked about single and elastic pool. The next one is Azure SQL Managed Instance. So the single database and elastic pool options restrict some of the administrative features available to SQL Server. Managed instance effectively runs a fully controllable instance of SQL Server in the cloud. You can install multiple databases on the same instance. You have complete control over the instance, much as you would have in an on-premises server. The managed instance service automates backups, software patching, database monitoring, and other general tasks. But you have full control over security, resource allocation for your databases. And the managed instance depend on other Azure services such as Azure Storage for backup, Azure Event Hub for any sort of telemetry, and Azure Active Directory for authentication, and Azure Key Vault for transparent data encryption or TDE, and couple of Azure platform services that provide security and support. So all communication between managed instance and these Azure services are encrypted and signed using certificates. So what are the use cases for managed instance? So consider Azure SQL Database managed instance. If you want to lift and shift an on-premises SQL Server instance and all its databases to the cloud without incurring the management overhead of running SQL Server on a virtual machine. As well as Azure SQL Database, Azure Data Services are available for other popular SQL-based database solutions as well. Currently, data services are available for PostgreSQL, MySQL, and MariaDB. So first, let's understand what is Azure Database for PostgreSQL. If you prefer PostgreSQL, you can choose Azure Database for PostgreSQL to run your PaaS implementation to PostgreSQL in Azure Cloud. This service provides the same availability, performance, scaling, security, and administrative benefits to MySQL service. Some features of on-premises Postgre database are not available in Azure Database for PostgreSQL. These features are mainly concerned with the extension that users can add to their database to perform specialized tasks, such as writing stored procedures in various programming languages and interacting directly with this operating system. Azure Database for PostgreSQL has two deployment options, a single server option and a hyperscale option. Alright, so now let's go and understand what is Azure Database for MySQL. Azure Database for MySQL is a PaaS implementation of MySQL in the Azure cloud based on MySQL Community Edition. The Azure Database for MySQL service include high availability at no additional cost and scalability as required. You only pay for what you use. Automatic backups are provided with point-in-time restore. The Azure Database for MySQL provides a global database system that scales up the large database without the need to manage hardware, network components, virtual servers, software patches, and other underlying components. So what are some of the benefits of Azure Database for MySQL? Azure Database for MySQL gives you high availability features built in, gives you predictable performance, easy scaling that responds quickly to demand, enterprise level security and compliance. And the next one is MariaDB. So what is Azure Database for MariaDB? So Azure Database for MariaDB is an implementation of the MariaDB database management system adapted to run in Azure. It's based on MariaDB Community Edition. The database is fully managed and controlled by Azure. So once you have provisioned the service and transfer the data, the system requires almost no additional administration. So what are some of the benefits of Azure Database for MariaDB? It gives you built-in high availability with no additional cost, scaling as needed within seconds, automatic backup and point-in-time restore up to 35 days, and enterprise-grade security and compliance. Alright, so that concludes this lesson. In the next video, we're going to explore how to deploy relational database offerings in Azure. And let's look at what are the learning objective on this video. We will learn about how to provision relational data services, how to configure relational data services, and we will explore some basic connectivity issues as well. And finally, we will touch upon how to explore data security. So without wasting any more time, so before we move forward, I just want to explain to you what is provisioning. Provisioning is an act of running series of tasks that a service provider, such as Azure SQL Database, performs to create and configure a service. Behind the scenes, the service provider will set up the various resources, such as disk, memory, CPU, network, and so on, required to run the service. You will be assigned these resources and they remain allocated to you and charged to you until you delete these services. Let us understand, what do you need to configure relational data services in Azure. First, let's look at the basics. You need an active Azure subscription. Then you go ahead and create a resource group. Then you create a managed instance or a database based on the server name what you give. Provide the admin login, password, select the right region, and select the compute and storage, and you go to the next step. Next configuration is network connectivity. This is where you configure the VNet, firewall rules, connection type, etc. There are some additional settings as well where you can decide the data source, server collation, time zone, etc. You can absolutely create tags for these resources. And the final step is to review and create. After the validation, Azure will start creating these resources for you. All right, so now we understood what are the basic things we need to set up the Azure SQL Database instance. Let me take you through a walkthrough to show you how you can provision and create an Azure SQL Database. You can navigate to Azure by going into portal.azure.com. Provide the username and password. And now you are inside the Azure portal. You can basically create any resources within this portal. Resources like virtual machines, storage accounts, networking, etc. So for this demonstration, I'm going to create an Azure SQL database. You can go to all services and search for databases, and you would be able to find Azure SQL. As you can see that I don't have an Azure SQL database. I'm going to click on Create an Azure SQL resource. This will give me an option to create either a SQL database, is it a single, elastic, or a database server. This is what we have learned. And then we have an option to create a SQL managed instance as well. Or if you do want to host an SQL on a virtual machine, which we learned in the previous video, you have an option to create that as well. Wherein if you notice, you can use either a free SQL Server license or bring your own license as well. For this demonstration, I'm going to create an SQL database, which is a single database. So click on Create. By default, you will have a subscription. Most cases, you will only have one subscription. So select the subscription. Choose a resource group where you want to place this database. You can either select an existing resource group or you can create one. So I'm going to create a new resource group. I'm going to call the resource group as DP-900. Click OK and enter your database name. If you have a server already, you can select that. In our case, we don't have a server, so I'm going to create a new database server. So provide a unique name and enter the administrative credential. And you can select the location where you want to host this database server. I'm going to go with East US. Select OK. Now you have your server ready. This is where you can make a decision. Do you want to make this a single pool or an elastic pool? If you select an elastic pool, you have an option to select an elastic pool or you can create one. I'm going to keep it as single. From the compute and storage point of view, this is where you can configure the database and choose which tier you want to take. So we have options like basic, standard, premium, and vCore model as well. So I'm going to go with a standard plan. DTU is where I can customize the processing unit, which include the memory, processing power, and the CPU, which is allocated for this database. If you want to know more what is DTU, you can click on this link, which takes you to your Microsoft doc, which help you understand how you can compare the DTU based service tiers. So maximum of 250 GB is the storage size which is allocated for this database, but you can decide how much storage space you want and hit on apply. Click next to go to the networking tab. This is where you can define how do you want to give access to your database. You can either expose to public endpoint or you can expose to a private endpoint, and you can define the private endpoint here. In my case, I'm going to leave it as no access. Go to additional settings. This is where you can configure. Do you want to have an existing data source? Do you want to have any backup, or do you want to include any sample database as well? So I'm going to include the Adventure Work LT sample database. Next to tag, I'm not going to allocate tag, but this is where you can allocate tags as well. And hit on create. The whole process won't take more than a couple of minutes. Looks like our deployment has started. So you can review the progress of the deployment on this page. So looks like our deployment has been completed. You can click on go to resource to straight away take you to the Azure SQL resource. As you can see that our database is created. Under the overview tab, this is where you can find the database details. You have plenty of option to configure a lot of things. If you want to connect to the database server, you can select the server name and you can straight away go to your SQL Management Studio and connect to your Azure SQL database. Before connecting, let me give you a quick tip. You go to the set the server firewall, and this is where you need to add your client IP address. So click on add client IP address. Basically, that lets you add the IP address of the local machine. And then once you hit and save, then you would be able to connect to the database from your local machine. Another way of accessing the database is to go to the query editor. So I'm going to sign in with the username and password we created for the server. As you notice, I can't log into the server because my client IP is not added. So I'm going to go back to the overview tab, set the server firewall, add the client IP, and I'm going to save the settings. Looks like my details is being updated in the firewall rules. I'm going to go back to the database and go to the query editor and provide the password for the user. So now within this, you would be able to access the tables. And from within this portal, you would be able to now run the query, or you can go to the tables to view the details as well. So that's a quick demonstration on how to create and provision an Azure SQL database instance. All right, so that concludes this lesson. In the next video, we're going to learn about how to query relational data in Azure. Some of the learning objective in this lesson is you will be able to describe query techniques for data using the SQL language, and you would be able to query relational data as well. So without wasting any more time, let's get into it. So let me give you an introduction to SQL. SQL stands for Structured Query Language. SQL is used to communicate with a relational database. It's the standard language for relational database management system. SQL statements are used to perform tasks such as update data in a database or retrieve data from a database. Some common relational database management systems that use SQL include Microsoft SQL Server, MySQL, PostgreSQL, MariaDB, and Oracle. Please note that SQL was originally standardized by an American National Standard Institute called ANSI in 1986 and by the International Organization of Standardization ISO in 1987. Since then, the standard has been extended several times as relational database vendors have added new features to their systems. Additionally, most database vendors include their own proprietary extensions that are not part of the standard as well, which has resulted in a variety of dialects of SQL. You can use SQL statements such as select, insert, update, delete, create, and drop to accomplish almost anything that one needs to do with a database. Although these SQL statements are part of the SQL standard, many database management systems also have their own additional proprietary extensions to handle the specifics of database management system. Now let's go and understand what are the SQL standard types. First, let's understand DML. DML stands for Data Manipulation Language. You use DML statements to manipulate the rows in a relational table. These statements enable you to retrieve query data, insert new rows, or edit existing rows. You can also delete rows if you don't need them anymore. The four main DML statements are select, which allow you to select or read rows from a table. Then we have insert, which allow you to insert new rows into a table. We have update, which will help you edit and update existing rows, and delete, which will give you an ability to delete existing rows in a table. All right, so now let's go and understand what is DDL. DDL stands for Data Definition Language. You use data definition language statements to create, modify, and remove tables and other objects in a database, which are table store procedures, views, and so on. Some of the most common DDL statements are create, alter, drop. So create is when you use to create a new object in the database, such as table or a view. Alter is to modify the structure of the object, for instance, altering a table to add a new column. And drop is used to remove an object from the database. Another common statement is rename. You can use rename to rename an existing object. One warning though, the drop statement is super powerful. When you drop a table, all the rows in the table are lost. Unless you have a backup, you won't be able to retrieve this data. And the third type is DCL. DCL stands for Data Control Language. A DCL is a syntax similar to a computer programming language used to control access to a data stored in a database. Example of a DCL command are grant, revoke, and deny. Grant is to allow specified users to perform specified tasks, and revoke is to remove the user accessibility to database object. Let's understand what are the different types of query tools available. You run SQL commands from tools and utilities that connect to the appropriate database. The tooling available depends on the database management system you are using. So let me take you through one by one. To use these tools, you first need to establish a connection to the database. You will require the details of the server to connect to and an Azure SQL database account, a username and password that has access to the server, and the name of the database to use on the server. You can find the server name for the database using the Azure portal. You can go to the Azure SQL database and go to the overview page. Then you can find the fully qualified server name in the server name field. Some tools and applications require a connection string that identifies the server, database, account name, and password. So, like we have seen in the previous example, you can use Azure portal to query the database. To access the query editor in the Azure portal, go to the page for your database and select the query editor. You will be prompted for credentials, and you can set the authentication type to either SQL Server Authentication or Azure Active Directory Password Authentication. So you enter the SQL query in the query plane and then click Run to execute it. Any rows that are returned appear in the results pane. The message pane displays the information such as the number of rows returned and any errors that occurred. Another tool what you can use is SQL CMD. The SQL CMD utility runs from the command line and is also available in the Cloud Shell. You specify parameters that identify the server, database, and your credentials. Please note that to use SQL CMD utility from the command line, you must install the Microsoft command line utilities on your computer. Another tool what you can use is Azure SQL Data Studio. Azure Data Studio is a graphical utility for creating and running SQL queries from your desktop. The first time you run Azure Data Studio, the welcome page should open and you need to fill in the following details like server name, authentication, username, password, database name, and server group to connect to your database. And SQL Server Management Studio is another tool that you can download and run on your desktop. And basically that gives you an ability to connect your database and perform all management tasks. All right, so that concludes this lesson. And this was the end of Module 2. In the next video, we're going to do a quick knowledge check on the Module 2 on the things what we have learned. So let's look at the first question. Which deployment requires the fewest changes when migrating an existing SQL Server on-premises solution? Is it Azure SQL Database Managed Instance? Definitely not. Is it Azure SQL Database Single Database? No. So the correct answer is SQL Server running on virtual machine. The SQL server running on virtual machine supports anything on-premises solution has. Let's look at the question number 2. Which of the following statement is true about SQL server running on a virtual machine? So I'm going to read out these statements to find out which one is the right one. You must install and maintain the software for the database management system yourself, but backups are automated. Definitely not. That is not a correct statement. The second statement is software installation and maintenance are automated, but you must do your own backups. This is again completely wrong. This is not automated. So the last statement is you are responsible for all software installation and maintenance and performing backups. Absolutely correct. So the SQL server running on a virtual machine, you are responsible for patching and backing up. Let's look at the third question. Which of the following statement is true about Azure SQL database? Scaling up doesn't take effect until you restart the database. No. Scaling out doesn't take effect until you restart the database. Not true. Scaling up and out will take effect without restarting the SQL database. Absolutely correct. You can scale up or out without interrupting the usage of the database. Let's look at question number 4. When using an Azure SQL database managed instance, what is the simplest way to implement backups? Is it manual configuration of the SQL server? Definitely not. Is it create a scheduled task to backup? No. So the correct answer is backups are automatically handled. A managed instance comes with the benefit of automatic backups and the ability to restore to a point in time. All right, so let's go through the last question. What is the best way to transfer the data in a PostgreSQL database running on premises into a database running Azure database for PostgreSQL service? Is it export the data from the on-premises database and import it manually into the database running in Azure? Definitely not. Is it upload a PostgreSQL database backup file to the database running in Azure? No. So the correct answer is use the Azure Database Migration Service or DMA. The Database Migration Service offers the safest way to push your on-premises PostgreSQL database into Azure. Alright, so that concludes the knowledge check on Module 2. In the next video, we are starting a brand new module, which is Module 3. And the first lesson is explore non-relational data offerings in Azure. Let's look at some of the learning objectives in this video. We will explore the use case and management benefits of Azure Table, Azure Blob, Azure Files, and Azure Cosmos DB in this lesson. So without wasting any more time, let's get into it. So let us first explore what is Azure Table Storage. Azure Table Storage implements NoSQL key value model. In this model, the data for an item is stored as a set of fields, and the item is identified by a unique key. An Azure Table Storage is a scalable key value store held in the cloud. You can create a table using an Azure Storage account. So let me take you to the Azure Storage account and show you how you can create a table storage. So I logged into my Azure portal. So I'm going to go to Storage account. This time I'm going to create a brand new storage account for this demonstration. Click on Add to create a new storage account and select your existing subscription. And you can select an existing resource group or you can create a new resource group as well. I'm going to select an existing resource group, which I created for the previous demo, DP-900. This is where you will give the name for your storage account. So I'm going to call the storage account as DP-900 storage demo. I'm going to place it in US. I'm going to place it in East US. And the performance, I'm going to keep it in the standard. And the account kind, I'm going to select storage V2. And the replication, I just need locally redundant storage. I'm not going to go through any other parameters. I'm just going to hit on review create. After the validation, you can click on create. The storage accounts won't take much time to create. It hardly takes like 30 to 40 seconds to create your first storage account. So looks like our storage account is created. I'm going to click on go to resource. So within the storage account, you can either create a blob container, file share, tables, or queues. For this topic, I'm going to click on table. So this is where you would be able to create your table. And that's how you get started with your table storage creation. To help ensure fast access, Azure Table Storage splits a table into partitions. Partitioning is a mechanism for grouping related rows based on a common property or partition key. Rows that share the same partition key will be stored together. Partitioning not only helps to organize data, it can also improve scalability and performance. So before we move and explore the Azure Blob Storage, let me tell you what are the use cases and the management benefit of using Azure Table Storage. First thing we need to understand about Azure Table Storage is Azure Storage tables are schemaless and Azure tables are simpler to scale. It takes the same time to insert the data in an empty table or a table with billions of entries. An Azure storage account can hold up to 500 terabytes of data. A table can hold semi-structured data. There is no need to map and maintain the complex relationship typically required by a normalized relational database. And let me tell you a couple of disadvantages of storing the data in the Azure Storage Table Storage. Now let's explore Azure Blob Storage. Many applications need to store large binary data objects such as images and video streams. Microsoft Azure virtual machines use blob storage for holding virtual machine disk images. These objects can be several hundred of GBs in size. So Azure Blob Storage is a service that enables you to store massive amounts of unstructured data or blobs in the cloud. Like Azure Table Storage, you create blob using Azure Storage Account. So we have seen an example on how to create a storage account. For blob storage also, the process of creating a storage account is similar. Once you create a storage account, you can either scroll down on the left hand side to find the blob services, or right under the overview pane, you can find containers. Azure currently supports three different kinds of blob: block blobs, page blobs, and append blobs. And blob storage provides three access tiers. So let me tell you how to find what is an access tier. So when you try to create a storage account, after you provide all the resource group, the name, and the different type and kind, under the blob storage, you would be able to find what tier you are looking at. So we have three kinds: hot, cool, and archive. A hot tier is the default. You use this tier for blobs that can be accessed frequently. The blob data is stored on a high performance media. The second kind is cool tier. The cool tier has lower performance and incurs reduced storage charges compared to the hot tier. And the last kind is archive. This tier provides the lowest storage cost but with increased latency. The archive tier is intended for historical data that mustn't be lost but required only rarely. So what are the use cases and management scenarios for Azure Blob Storage? You can use Azure Blob Storage for serving images or documents directly to your browser in the form of static website, or you can store files for distributed access, streaming video and audio, or storing data for backup and restore, or disaster recovery and archiving. And you can use it for storing data for analysis by an on-premises Azure hosted service as well. Please note that Azure Blob Storage is also used as the basis for Azure Data Lake Storage. You can use Azure Data Lake Storage for performing big data analytics. So to create a container, you simply go to create a container, you can name a container, and you have three different types of access you can restrict, and hit on create. After you create the container, you can simply upload and download within the portal, or you could use the tools like Azure Storage Explorer to create and access these files and manipulate with the files as well. In the previous example, I have shown you the table storage. So using Azure Storage Explorer, you can access the table storage what we created as well. Once you access it, you would be able to create partition. I'm going to add a new partition, and you get the whole idea, right? So this is where you can add the partition key and row key values, etc. And you can click on insert. Similarly, you would be able to exit out of this and click on blob. And this is the folder we created. Again, You can upload or download data, and you can access more information via the Storage Explorer as well. Let's explore Azure File Storage. Azure File Storage enables you to create file shares in the cloud and access these file shares from anywhere within an internet connection. Azure File Storage exposes the file shares using the Server Message Block 3.0 or SMB 3.0 protocol. This is the same file sharing protocol used by many existing on-premises applications. These applications should continue to work unchanged if you migrate your file shares to the cloud. The application can be running on-premises or in the cloud, and you can control access to shares in Azure File Storage using authentication and authorization services available through Azure Active Directory domain services. So let me quickly show you how you can create an Azure File share. I'm going to go back to my Azure portal. Creating a storage account is exactly same like how we created for the table storage. And once you create a storage account, you can go to the Overview tab and click on File Share, or you can scroll down under the left-hand pane and you can find File Service. Click on File Service and create a new file share. And after you name the file share, you would be able to assign a quota. So I'm going to provide 100 GB as the quota, and you can decide the tiers as well. You can have a cool tier, hot tier, and transaction optimized. And click on Create. And that immediately creates your SMB file share. Once you have the file share, you can simply go inside the portal and upload, download files just like blob storage, or you can use the Storage Explorer to access these files. The best thing about this is you can click on Connect, and this gives you an option to choose a drive letter and copy the script and run it in your local PC so that it attaches to your local computer just like an SMB drive. So I'm showing you an example of a file share which I created, which is mounted on my local computer, just like how I would work on a network map drive. So what are the use cases and management benefit of Azure File Storage? You can use Azure File Storage for migrating existing application to the cloud, or share server data across on-premises and cloud, or integrate modern application with Azure File Storage, or you can simplify hosting high availability workload data. Now let's understand what is Azure Cosmos DB. Tables, blobs, and files are all specialized types of storage aimed to help to solve specific problems. Reading and writing a table is a significantly different task from storing data in a blob or processing a file. Sometimes you require a more generalized solution that enables you to store and query data more easily without having to worry about extract mechanism to performing these operations. This is where a database management system proves useful. Azure Cosmos DB is a multi-model NoSQL database management system. And Cosmos DB manages data as a partitioned set of documents. A document is a collection of fields identified by a key. The field in each document can vary, and a field can contain child documents. And many document databases use JSON to represent the document structure. So, what are the use cases and management benefit of using Azure Cosmos DB? You can use Azure Cosmos DB for IoT and telemetrics, and retail and marketing, gaming, and web and mobile applications as well. There are so many use case scenarios for Azure Cosmos DB. To give you an idea, Cosmos DB is a foundational service in Azure. Cosmos DB has been used by many of Microsoft products for mission critical application at global scale, including Skype, Xbox, Office 365, Azure, and many others. And Cosmos DB is suitable for many scenarios, including web and retail, gaming, IoT scenarios, retail and marketing, etc. Alright, so that concludes this lesson. In the next video, we're going to learn about how to deploy non-relational data services in Azure. And in this lesson, we will learn about how to provision non-relational data services, configure non-relational data services, explore the basic connectivity issues and data security components. So without wasting any more time, let's get into it. So let's learn about how to provision Cosmos DB. So before that, what is provisioning? Provisioning is the act of running a series of tasks that a service provider, such as Azure Cosmos DB, performs to create and configure a service. Behind the scenes, the service provider will set up the various resources like disk, memory, CPUs, network, and so on required to run these service. You will be assigned these resources and they remain allocated to you until you delete the service. So let me take you to the Azure portal and show you how you can provision a Cosmos DB. I'm on my Azure portal right now. You can search for Cosmos DB on the global search box, or you can go to all services and click on databases, or you can go to all services and you can search for Cosmos DB here as well and select the Cosmos DB. And you have an ability to pin or star this on your left hand navigation pane as well. So select the Cosmos DB. As you can see that I don't have a Cosmos DB at the moment. Click on add and create an Azure Cosmos DB. And we go through the same routine as well. Select the subscription, select an existing resource group or create a new resource group, enter a account name. As with a Cosmos DB account, each storage account must have a unique name that hasn't already been used by someone else. Then select the location. I'm going to keep it West US itself. And we have performance tier. Under the capacity mode, we have a provision throughput and a serverless, which is under preview right now. Account type is where I can enable prediction or non-prediction. And we have an option to select geo redundancy and multi-region rights as well. Under networking is where you can enable connectivity to all network or a specific public endpoint or a private endpoint. I'm going to keep it to all network. You can define the backup policy here and set your encryption optional tag and go to review and create and hit on create to create your Azure Cosmos DB account. The next topic is learning how to provision data lake storage. It's important for us to understand that if you're provisioning a data lake storage, you must specify the appropriate configuration setting when you create the storage account. You can't configure data lake storage after the storage account has been set up. So make sure when you go to create your Azure storage account, on the advanced tab of create storage account page, in the data lake storage Gen 2 section, select enabled for hierarchical namespace option. So that concludes this lesson. In the next video, we're going to learn about managing non-relational data stores in Azure. In this lesson, we will learn about how to upload data to a Cosmos DB database and learn how to query this data. And we will learn about upload and download data in an Azure storage account as well. So without wasting any more time, let's get into it. All right. So before I talk about Cosmos DB APIs, let me give you an understanding about what is Azure Cosmos DB. Azure Cosmos DB is a NoSQL database management system. It's compatible with some existing NoSQL systems, including MongoDB and Cassandra. So what are Cosmos DB APIs? You can access the data in a Cosmos DB database through a set of commands and operations, collectively known as APIs or Application Programming Interface. Cosmos DB provides its own native API called SQL API. This API provides a SQL-like query language over documents that enables you to retrieve documents using select statements. So let's understand what is a table API. This interface enables you to use the Azure Table Storage API to store and retrieve documents. The purpose of this interface is to enable you to switch from table storage to Cosmos DB without requiring you to modify your existing applications. Alright, so what is a MongoDB API? A MongoDB is another well-known document database with its own programmatic interface. Many organizations use on-premises. You can use the MongoDB API for Cosmos DB to enable a MongoDB application to run unchanged against a Cosmos DB database. And you can migrate the data in the MongoDB database to Cosmos DB running in the cloud as well, but continue to run your existing application to access this data. Let's understand Cassandra API. Cassandra is a column family database management system. This is another database management system that many organizations run on premises. The Cassandra API for Cosmos DB provides a Cassandra-like programmatic interface for Cosmos DB, and the Cassandra API requests are mapped to Cosmos DB document request. As with the MongoDB API, the primary purpose of the Cassandra API is to enable you to quickly migrate Cassandra databases and applications to Cosmos DB. And finally, let's understand Gremlin API. The Gremlin API implements a graph database interface to Cosmos DB. A graph is a collection of data objects and directed relationships. Data is still held as a set of documents in Cosmos DB, but the Gremlin API enables you to perform graph queries over the data. Using the Gremlin API, you can walk through the objects and relationship in the graph to discover all manner of complex relationships. You can use the data migration tool or DMA to import data to Azure Cosmos DB from a variety of sources. And you can see all the sources I listed here. Some of it is JSON, MongoDB, CSV files, Amazon DynamoDB, HBase, etc. The data migration tool is available as a download from GitHub or any other repositories. The tool guides you through the process of migrating data into a Cosmos DB database. You are prompted for the source of the data and the destination. The tool can either populate an existing container or create a new one if the specified container doesn't already exist. Please note that you can also use the data migration tool to export data from Cosmos DB container to a JSON file, either held locally or in an Azure Blob storage. Although Azure Cosmos DB is described as NoSQL database management system, the SQL API enables you to run SQL-like queries against Cosmos DB databases. These queries use a syntax similar to that of an SQL, but there are some differences. This is because the data in a Cosmos DB is structured as documents rather than tables. Azure Blob Storage is a suitable repository for holding large binary data such as images, videos, and audio files. In the last video, we talked about how to create a blob container. So let me take you to the Azure portal and show you what are the specifics of the container. So I'm going to go back to the storage account, select the storage account we created, and I'm going to click on containers. In Azure Storage Account, you store blobs in containers. A container provides a convenient way of grouping related blobs together, and you can organize blobs in a hierarchy of folders inside a container, similar to files in file system on disk. When you create a container, this setting supports anonymous read-only access for blobs. However, unauthenticated clients can't list blobs in the container. This means that they can only download a blob if they know its name and location within the container. To upload or download and manipulate any sort of files, you can very well use the Storage Explorer, which is available within the portal. You can either download Storage Explorer as a standalone application and you can install on your desktop as well. Let's understand what happens when you delete these files. Deleting a blob can reclaim the resources used in the storage container. However, if you have enabled the soft delete option for the storage account, the blob is hidden rather than removed, and you can restore it later. You can enable or disable soft delete in Azure portal and specify the time for which the blob is retained. If the blob isn't restored by the end of the retention period, it will be removed from the storage. So that concludes module 3. In the next video, we're going to quickly do a knowledge check based on the things what we have learned on previous videos. Okay, let's look at the first question. What are the elements of an Azure table storage key? Is it table name and column name? Definitely not. Is it a row number? No. So the correct answer is partition key and row key. The partition key identifies the partition in which row is located, and the rows in each partition are stored in a row key order. Let's look at the second question. When should you use a block blob and when should you use a page blob? Is it when you use a block blob for unstructured data that requires random access to perform read and write, and use a page blob for discrete object that rarely change? Not correct. Is it when you use a block blob for active data stored using the hot access tier and a page blob for data stored using cool and archive data access tier? No. So the correct answer is use a page block for blobs that require random read and write access, and use a block blob for discrete objects that changes infrequently. Let's look at question number 3. Why might you use Azure file storage? Is it to share files that are stored on premises with users located at another site? No. Is it to store large binary data files containing images or other unstructured data? Definitely not. It is to enable users at different sites to share files. So that's the correct answer. You can create file share in Azure File Storage, upload files to the file share, and grant access to the file share to remote users. Let's look at question number 4. Wow, that's a long question. You are building a system that monitors the temperature throughout a set of office blocks and sets the air conditioning in each room in each block to maintain a pleasant ambient temperature. Your system has to manage the air conditioning in several thousand buildings spread across the country and region, and each building typically contains at least 100 air conditioned rooms. What type of NoSQL data store is most appropriate for capturing the temperature data to enable it to be processed quickly? Is it write the temperature to the blob in Azure Blob Storage? No. Is it to store the data in a file stored in the share created using Azure File Storage? Definitely not. So the correct answer is send the data to the Azure Cosmos DB database and use Azure functions to process the data. So the Cosmos DB can ingest large volumes of data rapidly. A thermometer in each room can send the data to a Cosmos DB database, and you can arrange for an Azure function to run as each item is stored. The function can examine the temperature and kick off a remote process to configure the air conditioning in the room. Let's look at question number 5. What is provisioning? Is it turning a service to improve performance? Definitely not. Is it for providing other users access to external service? No. So the correct answer is provisioning is the act of running series of tasks that a service provider performs to create and configure a service. In Azure, you must provision a service before you can use it. What is a security principle? Is it a named collection of permissions that can be granted to a service, such as the ability to use the service to read, write, and delete data? Definitely not. Is it a set of resources managed by a service to which you can grant access? No. So the correct answer is an object that represents a user, group, service, or managed identity that is requesting access to Azure resource. Azure authentication uses security principle to help determine whether a request to access a service should be granted. All right, let's look at the last question. Which of the following is an advantage of using multi-region replication with Cosmos DB? Is it data will always be consistent in every region? No. Is it increased security for your data? Definitely not. The correct answer is availability is increased. Replication improves availability. If one region becomes inaccessible, the data is still available in other regions. So that concludes module 3. We just finished the knowledge check on module 3. The next video, we are entering a brand new module, and the lesson we are going to learn is components of a modern data warehouse. And in this lesson, we will explore data warehousing concepts, and we will explore Azure Data Services for modern data warehousing and modern data warehousing architecture and workload. And finally, we will explore Azure Data Services in Azure Portal as well. So without wasting any more time, let's get into it. A modern data warehouse might contain a mixture of relational and non-relational data, including files, social media streams, and Internet of Things sensor data. Azure provides a collection of services you can use to build a data warehouse solution, including Azure Data Factory, Azure Data Lake Storage, Azure Data Bricks, Azure Synapse Analytics, and Azure Analytics Services. You can use tools such as Power BI to analyze and visualize the data, generating reports, charts, and dashboards. Let's look at how you can combine batch and stream processing. A typical large scale business requires a combination of up to the second data and historical information. The up to the second data might be used to help monitor real time critical manufacturing processes where an instant decision is required. Other examples include streams of stock market data where the current prices are required to make informed split second buy or sell decisions. Historical data is equally important as well. This will give a business a more stabilized view of trends in performance. A manufacturing organization will require information such as the volumes of sales by product across a month, a quarter, or a year to determine whether to continue producing various items or whether to increase or decrease production according to a seasonal fluctuations. Any modern data warehouse solution must be able to provide access to the streams of raw data and the cooked business information derived from this data. As a data engineer working at an organization with a large manufacturing operation, you want to understand more about the components that form a data warehouse. This information will help you determine which elements most closely meet your organization's requirement. So, we will start with understanding what is a data factory. Azure Data Factory is described as a data integration service. The purpose of Azure Data Factory is to retrieve data from one or more data sources and convert it into a format that you processes. The data sources might present data in different ways and contain noise that you need to filter out. Azure Data Factory enables you to extract the interesting data and discard the rest. The interesting data might not be in a suitable format for processing by the other services in your warehouse solution, so you can transform it. For example, your data might contain dates and time formatted in different ways in different data sources. And you can use Azure Data Factory to transform these items into a single uniform structure. The Azure Data Factory can then write the ingested data to a data store for subsequent processing. You define the work performed by the Azure Data Factory as a pipeline of operations. A pipeline can run continuously as data is received from the various data sources. And you can create pipelines using graphical user interface provided by Microsoft or by writing your own code. This image is an example on how this pipeline editor looks like in the Azure Data Factory. So what is Azure Data Lake Storage? A data lake is a repository for large quantities of raw data. Because the data is raw and unprocessed, it's very fast to load and update. But the data hasn't been put into a structure suitable for efficient analysis. You can think of data lake as a staging point for your ingested data before it's messaged and converted into a format suitable for performing analytics. Please note that a data warehouse also stores large quantities of data, but the data in a warehouse has been processed to convert it into a format for efficient analysis. A data lake holds raw data, but a data warehouse holds structured information. You can use a service such as Azure Data Factory to ingest and load data from a variety of sources into Azure Data Lake Storage. What is Azure Databricks? Azure Databricks is an Apache Spark environment running on Azure to provide big data processing, streaming, and machine learning. Apache Spark is a highly efficient data processing engine that can consume and process large amounts of data very quickly. There are a significant number of Spark libraries you can use to perform tasks such as SQL processing, aggregations, and to build and train machine learning models using your data. Azure Databricks provides a graphical user interface where you can define and test your processing step by step before submitting it to a set of batch tasks. You can create Databricks scripts and query data using language such as R, Python, and Scala. You write your Spark code using notebooks. A notebook contains cells, each of which contain a separate block of code. When you run a notebook, the code in each cell is passed to Spark in turn for execution. This image is an example which shows a cell in a workbook that runs a query and generates a graph. What is Azure Synapse Analytics? Azure Synapse Analytics is an analytics engine. It's designed to process large amounts of data very quickly. Using Synapse Analytics, you can ingest data from external sources such as flat files, Azure Data Lake, or other database management system, and then transform and aggregate this data into a format suitable for analytics processing. You can perform complex queries over the data and generate reports, graphs, and charts. Reading and transforming data from an external source can consume considerable resources. So Azure Synapse Analytics enable you to store the data you have read in and processed locally within the service. This approach enables you to repeatedly query the same data without the overhead of fetching and converting it each time. You can also use this data as an input to further analytical processing using Azure Analysis Services. So, what is Azure Analysis Services? Azure Analysis Services enable you to build tabular models to support online analytical processing or OLAP queries. You can combine data from multiple sources, including Azure SQL Database, Azure Synapse Analytics, Azure Data Lake Store, Azure Cosmos DB, and many other. You use these data sources to build models that incorporate your business knowledge. A model is essentially a set of queries and expressions that retrieve data from the various data sources and generate results. The results can be cached in memory for later use, or they can be calculated dynamically directly from the underlying data sources. Analysis services include a graphical designer to help you connect data sources together and define queries that combine, filter, and aggregate data. You can explore this data from within analysis services, or you can use a tool such as Microsoft Power BI to visualize the data presented by these models. And let's understand what is Azure HD Insight. Azure HD Insight is a big data processing service that provides the platform for technologies such as Spark in an Azure environment. HD Insight implements a clustered model that distributes processing across a set of computers. This model is similar to that used by Synapse Analytics, except that the nodes are running the Spark processing engine rather than Azure SQL Database. So that concludes this lesson. In the next video, we're going to explore data ingestion in Azure. In this lesson, we will learn about how to describe data ingestion in Azure, describe components of Azure Data Factory, and see how to use Azure Data Factory to load data into a data warehouse. So without wasting any more time, let's get into it. Data ingestion is the first part of any data warehousing solution. It is arguably the most important part. If you lose any data at this point, then any resulting information can be inaccurate, failing to represent the facts on which you might base your business decisions. In a big data system, data ingestion has to be fast enough to capture the large quantities of data that might be heading your way and have enough compute power to process this data in a timely manner. Azure provides several services you can use to ingest data. These services can operate with almost any source. Some of the popular tools used within Azure is Azure Data Factory, or known as ADF, then Polybase, and SQL Server Integration Services, or SSIS, and Azure Databricks. Azure Data Factory uses a number of different resources like linked services, datasets, and pipelines. So let me help you understand each one by one. Data Factory moves data from data source to a destination. A linked service provides the information needed for Data Factory to connect to a source or destination. For example, you can use an Azure Blob Storage link service to connect to a storage account to Data Factory, or Azure SQL Database link service to connect to an SQL database. Let's understand datasets. A dataset in Azure Data Factory represents the data that you want to ingest, input, or store, which is output. If your data has a structure, a dataset specifies how the data is structured. Not all datasets are structured. Blobs held in Azure Blob Storage are an example of an unstructured data. Now let's understand what is pipeline. A pipeline is a logical grouping activity that together perform a task. The activities in a pipeline define actions to perform on your data. For example, you might use a copy activity to transform data from a source dataset to a destination dataset. You could include activities that transform the data as it is, or you might combine data from multiple sources together. Other activities enable you to incorporate processing elements from other services. For example, you might use an Azure function activity to run an Azure function to modify and filter data, or Azure Databricks notebook activity to run a notebook that performs more advanced processing. So that concludes this lesson. In the next video, we're going to explore data storage and processing in Azure. The most common options for processing data in Azure include Azure Databricks, Azure Data Factory, Azure Synapse Analytics, and Azure Data Lake. So let me take you through these one by one. What is Azure Synapse Analytics? Azure Synapse Analytics is a generalized analytics service. You can use it to read data from many sources, process this data, generate various analytics and models, and save the results. You can select between two technologies to process the data. You can either use Transact SQL or Spark. Let's look at what is Azure Databricks. Azure Databricks is an analytics platform optimized for Microsoft Azure Cloud Services platform. Designed with the founders of Apache Spark, Databricks is integrated with Azure to provide one-click setup, streamlined workflows, and an interactive workspace that enables collaboration between data scientists, data engineers, and business analysts. Databricks can process data held in many different types of storage, including Azure Blob Storage, Azure Data Lake Store, Hadoop storage, flat files, databases, and data warehouses. Databricks can also process streaming data, and Databricks uses an extensible architecture based on drivers. Let's understand what is Azure HT Insight. Azure HT Insight is a managed analytics service in the cloud. It's based on Apache Hadoop, a collection of open source tools and utilities that enable you to run processing tasks over large amounts of data. HT Insight uses a clustered model similar to that of a Synapse Analytics. HT Insight stores data using Azure Data Lake Storage, and you can use HT Insight to analyze data using frameworks such as Hadoop Map, Reduce, Apache Spark, Apache Hive, Apache Kafka, Apache Storm, R, and more. Let's understand what is Azure Data Factory. Azure Data Factory is a service that can ingest large amounts of raw, unorganized data from relational and non-relational systems and convert this data into meaningful information. Data Factory provides a scalable and programmable ingestion engine that you can use to implement complex hybrid ETL and ELT and data integration projects. And what is Data Lake Store? Data Lake Store provides a file system that can store near limitless quantities of data. It uses a hierarchical organization, and like the Windows and Linux file system, but you can hold massive amounts of raw data and structured data. It is optimized for analytics workloads. Azure Data Lake Store is compatible with Hadoop Distributed File System or HDFS, and you can run Hadoop jobs using Azure HT Insight that can read and write data in Data Lake Store efficiently. Let's explore Azure Synapse Analytics. Azure Synapse Analytics is an integrated analytics service that allows organizations to gain insights quickly from all their data at any hyperscale, from both data warehouses and big data analytics systems. Azure Synapse is composed of following elements. The first is Azure Synapse SQL Pool. This is a collection of servers running TSQL in a dialect of SQL used by Azure SQL Database and Microsoft SQL Server. Then we have Synapse Spark Pool. This is a cluster of servers running Apache Spark to process data. You write your data processing logic using one of the four supported language, which is Python, Scala, SQL, and C Sharp. Then we have Synapse Pipelines. A Synapse pipeline is a logical grouping of activities that together perform a task. The activities in a pipeline define actions to perform on your data. For example, you might use a copy activity to transform data from a source dataset to a destination dataset. Then we have a Synapse link. This component allows you to connect to Cosmos DB. You can use it to perform near real-time analytics over these operational data stored in a Cosmos DB database. And finally, we have Synapse Studio. This is a web user interface that enables data engineers to access all the Synapse analytics tool. And you can use Synapse Studio to create SQL and Spark pools and define and run pipelines and configure links to external data sources. Alright, so that concludes this lesson. In the next video, we're going to learn about how to get started building with Power BI. In this lesson, we will learn about how Power BI services and application work together, and we will explore how Power BI can make your business more efficient. And towards the end, we will learn about how to create a compelling visuals and reports. So without wasting any more time, let's get into it. Microsoft Power BI is a collection of software services, apps, and connectors that work together to turn your unrelated sources of data into coherent, visually immersive, and interactive insights. Whether your data is a simple Microsoft Excel workbook or a collection of cloud-based and on-premises hybrid data warehouses, Power BI lets you easily connect to your data sources, visualize what's important, and share that with anyone and everyone you want. Power BI can be simple and fast, capable of creating quick insights from an Excel workbook or a local database. And Power BI is also robust and enterprise grade ready, not only for extensive modeling and real time analytics, but also for custom development. Therefore, it can be your personal report and visualization tool, but can also serve as an analytics and a decision engine behind group projects, divisions, or entire corporations. And Power BI consists of a Microsoft Windows desktop application called Power BI Desktop, an online SaaS service called Power BI Service, and mobile Power BI apps that are available on any device with native mobile BI apps for Windows, iOS, and Android. So these three elements, Power BI Desktop, the service, and the mobile apps, are designed to let create, share, and consume business insight in the way that serves them or their role most efficiently. So how you use Power BI might depend on your role on a project or a team. For example, you might view reports and dashboards in Power BI service, and that might be all you do with Power BI. But your number crunching, business report creating coworker might make extensive use of Power BI Desktop. You also might use each elements of Power BI at different times, depending on what you are trying to achieve or what your role is for a given project or effort. So everything you do in Microsoft Power BI can be broken down into a few basic building blocks. After you understand these building blocks, you can expand on each of them and begin creating elaborate and complex reports. After all, even seemingly complex things are built from basic building blocks. For example, buildings are created with wood, steel, concrete, and glass. And cars are made of metal, fabric, and rubber. And of course, buildings and cars can also be basic or elaborate, depending on how those basic building blocks are arranged. So let's look at the basic building blocks for Power BI. The basic building blocks are visualizations, data sets, reports, dashboards, and tiles. So let's look at these elements in detail. First one is visualizations. A visualization is a visual representation of data like a chart, a color coded map, or other interesting things you can create to represent your data visually. Power BI has all sort of visualization types and more are coming all the time. This example shows a collection of different visualization that were created in Power BI service. Visualization can be simple, like a single numbers that represent something significant, or they can be visually complex, like a gradient colored map that shows voter sentiment about a certain social issue or concern. The goal of a visual is to present data in a way that provides context and insights, both of which would be probably be difficult to discern from a raw table of numbers or text. So what is data sets? A data set is a collection of data that Power BI uses to create its visualizations. You can have a simple data set that's based on a single table from a Microsoft Excel workbook similar to what's shown in this image. Dataset can also be a combination of many different sources, which you can filter and combine to provide a unique collection of data for use in Power BI. The next element is reports. In Power BI, a report is a collection of visualization that appear together on one or more pages, just like any other report you might create for a sales presentation or write for a school assignment. A report in Power BI is a collection of items that are related to each other. So the next elements are dashboards and tiles. When you are ready to share a single page from a report or a collection of visualization, you create a dashboard, much like the dashboard in a car. A Power BI dashboard is a collection of visuals from a single page that you can share with others. So what are tiles? In Power BI, a tile is a single visualization on a report or a dashboard. It's the rectangular box that holds all the individual visual. When you are creating a report or a dashboard in Power BI, you can move or arrange tiles however you want. You can make them bigger or change their height or width and snuggle them up to other tiles. Alright, so that concludes this module 4. Now in the next video, we're going to quickly do a knowledge check on all the things what we have learned on the previous videos. So the first question is, when should you use Azure Synapse Analytics? Is it to enable large number of users to query analytics data? No. Is it to create dashboards from tabular data? No. So the correct answer is to perform very complex queries and aggregations. Azure Synapse Analytics is suitable for performing compute-intensive tasks such as these. Let's look at question number 2. What is the purpose of data ingestion? Is it to perform complex data transformation over data received from external sources? No. Is it to visualize the results of data analysis? No. So the correct answer is to capture data flowing into a warehouse system as quickly as possible. Data ingestion can receive data from multiple sources, including streams, and must run quickly enough so that it doesn't lose any incoming data. Let's look at question number 3. What is the primary difference between a data lake and data warehouse? Is it a data lake contains structured information, but a data warehouse holds raw business data? No. Is it a data stored in a data lake is dynamic, but information stored in data warehouse is static? Definitely not. So the correct answer is data lake holds raw data, but a data warehouse holds structured information. A data warehousing solution converts the raw data in a data lake into meaningful business information in a data warehouse. Which component of an Azure Data Factory can be triggered to run data ingestion task? It's definitely not CSV and linked service. So the correct answer is pipeline. Pipelines can be triggered to run activities for ingesting data. When might you use Polybase? Is it to orchestrate activities in Azure Data Factory? No. Is it to ingest streaming data using Azure Databricks? Definitely not. So the correct answer is to query data from external sources from Azure SQL database. because this is the purpose of Polybase. Let's look at question number 6. Which of these services can be used to ingest data into Azure Synapse Analytics? Is it Azure Active Directory? No, it's definitely not Power BI. So the correct answer is Azure Data Factory. Azure Data Factory can be used to ingest data into Azure Synapse Analytics from almost any source. Let's look at question number 7. You have a large amount of data held in files in Azure Data Lake storage. You want to retrieve the data in these files and use it to populate tables held in Azure Synapse Analytics. Which processing option is most appropriate? Is it Azure Synapse Spark Pool? No. Is it to use Azure Synapse Link to connect to Azure Data Lake storage and download the data? Completely wrong. So the correct answer is Synapse SQL Pool. You can use Polybase from SQL Pool to connect to the files in Azure Data Lake as external tables and then ingest the data. Let's look at question number 8. Which of the components of the Azure Synapse Analytics allow you to train AI models using Azure ML? Is it Synapse Studio? No, it's definitely not Synapse Pipelines. So the correct answer is Synapse Spark. You would use a notebook to ingest and shape data and then use Spark ML and Azure ML to train models with it. Let's look at question number 9. In Azure Databricks, how do you change the language a cell uses? Is it to wrap the command in the cell with the language? No. Is it to change the notebook language before writing the commands? Not right. So the correct answer is the first line in the cell is language. For example, percentage Scala. Each cell can start with the language definition. Let's look at question number 10. What is the common flow of activity in Power BI? So the correct answer is bring data into Power BI desktop and create a report and share it with the Power BI service. View and interact with reports and dashboards in the service and Power BI mobile. So this is the correct flow. The Power BI service lets you view and interact with reports and dashboards, but doesn't let you shape data. Let's look at question number 11. Which of the following are building blocks of Power BI? It's definitely not tiles, dashboard, database, and mobile devices, and it's not Visual Studio, C Sharp, and JSON files. The correct answer is visualizations, datasets, reports, and dashboard tiles. Why? Because building blocks of Power BI are visualizations, datasets, reports, dashboards, and tiles. And the last question is a collection of ready-made visuals pre-arranged in dashboards and reports is called what in Power BI? It is called as an app, because an app is a collection of ready-made visuals pre-arranged in dashboards and reports. You can get apps that connect to many online services from the app source. So that concludes the tutorials on DP-900, which was Azure Data Fundamentals. Thank you so much for listening, and I really hope the content which I provided was useful. Until I see you on the next certification tutorial, you guys take care.